You'll get announcements in the future. So if you haven't done that already, I would highly encourage you after this meetup to do that. Another place to find a lot of people that were in this room and that participate in these meetings is through IRC. Specifically on Freenode, the Pound Drupal-Colorado is where a lot of the folks in this group will be there. It's a great way to ask questions after this meeting, and we also will be looking for future presentations. So if you're interested, please contact us. We're about ready to start the live stream in probably 3 or 4 minutes. So just because we want to, how many viewers do we have so far? I don't know yet, but we're going to actually live record this. So after this talk, hopefully, it will stream and basically it's going to go through YouTube and they'll save it there. So if you want to review anything that's been presented here, there's going to be 2 locations. The Media GitHub account has a copy of every one of our presentations from this meeting, so you can actually go through and tab through them, very much like SlideShare. And then the recording will be on our Google Plus page, which we'll link to the meeting announcement that you probably all got to come here. So without further ado, I'm going to introduce David Arnold, who's joined our team about 3 months ago, correct? And he will be presenting a lot more on the DevOps side, specifically on aspects of Chef and test-driven development and so forth. So for those that are more from the Drupal side of things, this may be a little different than normal, but the concepts here are applied to what we're using in our Drupal cookbook or what we're trying to apply moving forward with the work we're doing at Media and at large and give back to the community. So without further ado, Sarah, and then we can probably just kick off the recording.
Okay. Looks like we're on, so. All right, so I'm David Arnold, and like Rick said, it's going to be a little bit different. It's not specifically going to be about Drupal, but we thought this would be an interesting topic to talk about. We use Chef pretty heavily, and it's what we use for our Drupal cookbook, which I'm not sure if you guys are familiar with. If not, I highly recommend checking it out. It's pretty awesome. It's a great way to deploy Drupal pretty quickly, and it leverages Chef. So first off, can I just kind of get a show of hands from you guys who's familiar with Chef, whether you use it possibly? Cool. So good majority of us. So really, we're going to talk about a project that's near and dear to my heart that I've been working on. And it's really available on GitHub, and I call it the MD Skeleton. So what is it? It's a skeleton cookbook, and it envelops a lot of different tools that we use with Chef. And as Rick said, we do a lot of test-driven development. That's really what we strive for when we do our cookbooks, is test-driven development. So what we'll cover is some of the tools that are incorporated with it. Like I said, it's up on GitHub, and I do recommend you check it out. So it's nice, but I don't know if you're familiar with Knife. The Knife is a tool within Chef. It is kind of like, it sounds like a Swiss Army knife, really. Lots of things you can do. You can manage server, and one of the other functions is you can create a base cookbook. Why we created our own skeleton cookbook is we want to extend the functionality. Knife lets you define through effectively a version, a license, and an author when you set it up, and then it builds that file structure for you. We use a lot more tools and packages when we're pushing recipes. So because of that, we created this project. So these are the main components that we have a skeleton tool. I'm not going to cover these all in just a minute, but bundler, rake, test kitchen, RSpec, FSpec, ServerSpec, Travis CI, and our favorite user is Food Critic. You know, Chef is very, I mean, you know, so is Pocket. You know, a lot of tools use different things. Chef is very Ruby centric and heavy Ruby. And so these are the tools that we use to kind of go around. So those of you guys that use Ruby are familiar with some of these tools. First one to talk about is Bundler. Bundler is a pretty wonderful tool because what Bundler does is it bundles your gems, and gems are pretty packages, right? Defined pieces of code that you can use. And what we specifically use Bundler for is abstracting away from using shared gems when Ruby defaults to having a shared gem directory, which is really smart. But when we want to be able to move these projects from environment to environment, we want to make sure that we're locking in these gems to certain versions, stuff like that. So we use Bundler to dictate that, hey, we want these specific gem versions to be installed, and we want them to be installed in a non-shared directory. So when we have somebody use Skeletor, when we use Skeletor, and any of our recipes, we can log in, clone the repository, go down and run bundle install, and it will take all of your defined gems and install them into a location that is specific for that recipe. So you never have to worry about gem versions and stuff like that being off, because you can lock them in the gem file, and that's what we have here. So, for example, a gem file, which is a different gem. I really like the logo that Bundler has. One of the things that I learned at this year's DrupalConf was that open source projects are much more successful if they have awesome logos. I think Bundler is one of those that are really awesome compared to the ones that don't have them. So, yeah, so this is just, like I said, this is an example here of a gem file, and this is just our Bundler config, which is in the root directory of our enemy skeleton. Next is Rake, and Rake is a Ruby build tool. You know, Make has been around for a long time. Every language has their own build tool, and Rake is just a Ruby build tool. But it is an awesome tool because it allows you to interact with the environment, have up certain jobs, kick off a lot of different functionality. It's all defined in a Rake file. So our Rake file in enemy Skeletor has a few different things that you can do. One of the big ones that I really enjoy is there is a Rake task. We'll go a little more in depth in it, but builds a README from the metadata file. If you're familiar with Chef, there is a metadata file. What we like to do, and one of the lessons we've learned, is abstracting all that README data in the metadata, because then we can reuse that data in other ways, not just for our READMEs. And it makes sense if we have a customer that wants certain documentation. We've already written the documentation, extracted away from, say, the README, and we can edit it just by running the Rake command, say, Rake README. It generates from that metadata file README, which is quite nice. Also run RSpec tests. We'll talk about RSpec in a minute. And then run our Ruby linters. So that's, you know, that's Rake. And this is just a small snippet from the Rake file that is in enemy Skeletor. And you'll notice that, you know, Rake can be just as simple as defining a task that says run Rubocop, or it can be much more complicated. It can break out to the shell, it can run all sorts of different things. The README, that's part of, not the entire README generation piece. The other part of our Rake task that we have for the README also goes out and gets the Git publishers and people that are committed to the Git repo, and then adds them to the credits in the README. So it's nice because it dynamically generates those and pulls that information from Git. That's how, if you guys don't know, we're big Git guys. So we use Git a lot, and that works out well for us, because it's another thing, a lot of people end up contributing to a project, so you never want to let that information get lost. As long as it's in the repo, that Rake task pulls it from Git, populates it in the README, so we know when we run that task at all. So this is a nice example of Rake, because like I said, there's a 2-line thing that does quite a bit, and there's much more to get on. But README actually has another function that's about twice as long as that, and that's just to get the credits for that. Git piece. Next, this is Rake tasks. So you define in the Rake file your task. This is just an output of the base ones that we have. Running linters, integration tests, generating your README. So this is just if you were to log in and you wanted to use Rake, Rake minus D will give you the definition and the explanation of all the tasks that are defined.
You run that relation, so.
Well, with Skeletor, you clone Skeletor down and you change directory into that clone directory. One thing I kind of flew past with Bundler, bundle install is your friend. It just takes and downloads all those gems, make sure they're in that shared location. And then you would just do either bundle exec, Rake minus D, to get this kind of thing, or Rake minus D as well. But bundle exec, and that's, sorry, I kind of skimmed over that. Bundle exec is what you kind of want to wrap everything with your hands, because using Bundler, it's going to always use those gems specific for that project. And that's kind of a big thing, because we run into a lot, especially for porting recipes in different environments, people that have Macs and other stuff that's going on there. We want to make sure those gems are the versions that we test with. So Rake is, you know, and I feel like I'm flying through it pretty quick, but Rake is really powerful because you can define just any task that you can think of.
ultimately we'll probably make a rake setup task in Skeletor, so you can say rake setup and have it prompt you for some more information. You can go through and even that information in Skeletor. Okay, you guys know Vagrant? Let me show your hands, guys use Vagrant. Cool. Test Kitchen as well. A little bit. So Test Kitchen is a wrapper for Vagrant, and it's pretty wonderful because you can, as it says up there, leverage to Vagrant test your code in isolation. It will do a Vagrant up, it will run defined recipes, it will run your tests, and then it will also destroy or leave up your Vagrant machine. So one of the big powerful things is you can do it for local development, but you can also do it for listed up there and more, right? So you can target Test Kitchen to a Docker instance or to Amazon or to your local machine and fire it up with VirtualBox, or you can fire it up, VMware, whatever. And the beauty of that is because it's a wrapper for Vagrant, you have a lot of different ways to find individual virtual machines, new recipes, all that kind of stuff. You can use testing frameworks. That's just kind of the four major ones that are used for us. We're very RSpec and server-spec centric, and we'll get that more in just a minute about RSpec and server-spec, but let's split those. Great. Like I said, use Chef Solo. If you use Chef Solo as a replication or an emulator, effectively, it takes place of the Chef server in a standalone environment. So you have a Chef client, you have a Chef server. The Chef server holds a lot of information, attributes, and stuff like that. You can find, using Test Kitchen, expected attributes that should be handed back to that box if you're in a local development environment. So Chef Solo is a very, very powerful and awesome tool. It's really easy to plug into Test Kitchen. But what's awesome about Test Kitchen is you don't even have to use Chef. It supports all sorts of other stuff. It supports Puppet, supports Salt, supports really everything that Vagrant does and more. And that's the beautiful thing about it. We're very Chef-centric, but we can also use Puppet to pull up our instances or run Puppet recipes and stuff like that. So, Test Kitchen is our big doer and part of what really pulls everything for us when we're doing testing. So testing, let's talk about RSpec and ChefSpec. I apologize, that's a relatively small graphic. So we use two different tools for testing. Right? We use RSpec kind of on the front end for our tests, and on the back end we use ServerSpec. We work in the TDD environments I mentioned earlier, so we strive to write our tests first and then write our functionality to those tests. And so essentially we're working in end state definition. We know that our configuration file needs to exist in a certain location. We know that configuration file may need to have certain data. So what we do is we write a test for that first. Then we write the recipe to do that. And that's really what we do in TDD. So I like to use the example because it's a straightforward one, the directory and that. So in this case, I'm writing a test in RSpec. Specifically, ChefSpec is a library or extension for RSpec. And I'm saying here, if you guys can see it, and I apologize again, is I expect it to create a directory called /docs, with owner groups, group, and a mode of service 755. And then I will go and then write a recipe to do that. What RSpec does specifically is it tests your Ruby code, spins up an in-memory system that's emulated, obviously, and it emulates whatever platform or whatever environment you tell it, and tests to see if your Ruby code is doing what you expect it to do, right? So we do it on the front end to say, okay, is our Ruby code going to create this directory? Is it going to make it with a root, that's the owner, and it's the group and all that other fun stuff. In Skeletor, when you look inside the RSpec directory, you'll notice that this test, it's not exactly similar to this, is in there. It's just a reference because there's a very neat method that we use that I actually got from Seth Fargo. One of his blog posts was to effectively target more than one environment, because when you bring up those in-memory environments, you can define it as Red Hat, as CentOS, as a certain operating environment, because as we know, paths are different, expectations are going to be different. So what you can do is this block of code allows you to target multiple operating systems and multiple versions. Now, RSpec is somewhat limited, right, because we're really doing an in-memory test. It's not firing up a full virtual machine, so you will run into some issues with RSpec. So we scope what we test with RSpec to primarily attributes and variables that are set by Chef, and then we use service spec to get into it and kind of fill out the rest of that. So RSpec for us is kind of testing on the front end, saying what are we going to do, what are we setting, is our Ruby written to do that? And if our test pass, great, we kind of move on, and if not, we keep working until it. So one of the nice things about RSpec and also server spec in a lot of regards too, but it's when you start stacking more and more functionality with recipes, one of the things that can happen is maybe everybody wants a piece of a certain configuration, a certain attribute, right? Maybe one person toggles postfix off, and the other recipe toggles it on, or vice versa. What you can do is when you pull all these recipes together, you can say, well, it's failing. I can look at my RSpec test and say, oh, this recipe expects postfix to be running as a service. This one expects it not to be. When I put them together, it's broken, and I can see very quickly which one in this complicated environment is actually munching the configuration that I need for that functionality. So when you write your tests for your functionality, and you start getting a more and more complex environment, it's kind of a beautiful thing because it makes it much faster for you to determine where are these conflicts. This is just an example of output from RSpec. You can run it locally, and we'll talk about Travis CI in a minute, which we also do locally. But this is just a test, and this is from another one of my favorite recipes that's up there, NMD base. I'd also recommend you guys check that out if you're interested. It's a recipe that we use as our base boxes to fire up all Ubuntu and CentOS boxes, though they work across Ubuntu family and to bring up a base box. So, it does all sorts of fun stuff. Enables LDAP authentication if you want, manage IP tables, set up users. You can, define whatever you want, and it's a pretty neat recipe. It's out there if you search for it. It's called NMD base. But this is an RSpec test. So you'll notice that, similarly we've defined, you can see those tests in that project. Well, that it includes these recipes, installs these services, just kind of goes through it and tells it passes. You'll notice that it's testing both Ubuntu and RHEL, and the default test that we have there, that example test we have there, we actually target 2 versions of RHEL and 2 versions of Ubuntu. Kind of working with, but you can easily change that to whatever. And then the other nice thing is it also creates a nice little coverage report. It's just some HTML that'll throw in whatever directory and tell you what percentage of your tests are actually working, right? So it's kind of an easy way to look at it. There's a lot of output. You kind of just stare at that last number and say, oh, well, I got 53% test coverage. Something's not right. And you'll look at that and it'll actually show you examples of all this stuff is, set up as a base in Skeletor. And it's kind of why I like Skeletor so much, because all these tools are there. We can rapidly start writing our recipes and not be like, oh, right, what was that one thing I was going to grab that does this? And have it there so we can. So server spec. Server spec is the other side of what we do with RSpec. Server spec is effectively run afterwards. Server spec will run tests against local machines, remote machines, anything you want. But what specifically we do in conjunction with Kitchen is that we will have it fire up a virtual machine. Server spec will go in and actually look at the box, right, and say, does this file actually exist? Is this service running? Is this service listening on this TCP port? Have I defined, something in my, settings.php? Is it there? It needs to be there. And that's the really nice thing about server spec is RSpec is testing our Ruby code. Server spec is looking at your results. Are you really getting what you expect? And with the combination of those two things, we can write these really good recipes relatively quickly because we're testing both the front and back end. So that's the nice thing about server spec. Here is just kind of a simple example. So server spec test. This one is checking to see if server spec, hostfix is enabled. Is the service set to start up? And also it's looking at Etsy hosts and saying, does the the loopback have an entry in Etsy host for 1%? Yeah, it looks at the line system, and that's the power of it, because you can have it look at your local dev environment, and then say you're moving to prod or a different environment, you can retarget server spec at a remote server and say, I have all these expectations for this to work. They will come back and say, these things failed. We can easily say, I can't put this into this environment, or there's something wrong with this environment. Here's what my expectations are, and this is what's different from dev, just in my Amazon, or, wherever you might happen to be using. So server spec is very, very powerful because it is looking at that live system. It's pretty awesome because of that. Yep, it is. It's a defined system the way it's expected to be, and that's another thing that can happen when you stack more complicated environments, or if you're trying to do a lot of codification on the same box.
They have to find the bugs in your box and changes stuff.
Well, and that's a great example. Is we just kind of ran into that situation. Is that we went to go do a deployment. There was a server that the client obviously has access to. They went in and hand hacked a bunch of values, and we can't deploy because this is different than our expectation. So we've got to go back and consolidate and reconcile these changes. Server spec is beautiful for that kind of stuff because if you write your tests effectively, especially in server spec, your deployments are just going to go beautifully because you're covering all your bases and you can identify that unique data that maybe, or the changes that might be stopping you before you can treat it.
And the test pretty much the same as RSpec?
It's similar. I mean, your functionality is there, but you'll look at the syntax when you go and look at RSpec and server spec, and the tests are, a little different. But we're talking about Ruby, so it's trying to be, very Ruby-esque. It's trying to be like, describe this service and it should be started, kind of thing. So it's, if you're comfortable in Ruby, then you're going to be absolutely comfortable in server spec and RSpec. So. Server spec, this is just, I'm going to show everything roses. This is a failed server spec test. And this one specifically is from, I think, our NMD base, again. And what I was doing was at pan SSHD, I've got it defined in my server spec tests. It should be a file, it should be mode 644, it should be, whatever you can see there. But what I've said is it should match this, it should have this for YubiKey PAN module. But it doesn't, and that's what this is a failed test. Saying all these other things fail, but I can very quickly say, oh, cool, you know what, something's wrong with that one line, or that one line is missing. It is space specific, so if I had sometimes like, oh, I have 2 tabs instead of space, but easily identify very quickly that stuff is Travis CI. How are things?
Does anybody here use Travis at all? Travis and Git?
Travis, if you use Git, is spectacular. Because it is a continuous integration service that is available for your Git projects, and it can be used to build and test projects. It builds up a virtual environment. It takes your Git project and tests it using your RSpec and server spec test. Or effectively anything you define. You can define Travis to do all sorts of things. We specifically use it, in this case, to target multiple versions of Ruby. 3 of them, 1.9.3, and then a couple of different, 2 different 2x versions. And it's really, really helpful, especially because I primarily want to develop in like 2.1, but I screwed up 1.9 a lot, primarily because it wants like that UTF quote at the beginning. So there's some stuff like that. So what Travis does, it will it's awesome. I am a fan, if you can't tell. It can be used to test anything, test Go, PHP for Drupal module development, and it's just a definition, and it'll build up whatever environments you want, and run those tests, and it'll be based off your pull request. So I'll put in a pull request. It'll come back and say, oh, 1.9.3 failed. Here's the reason why. We'll fix it. We use it as a part of our release management for this kind of stuff. This is a portion of a Travis run. Travis, I don't know if I mentioned, Travis is free for it's a certain amount of usage per day, which is a pretty awesome amount. So if you use Git, you can use Travis. It's free. This is a Travis run, and you can see that I did a pull request on this project. It went ahead and cloned it. And this is up on their servers. And then it starts running all the definitions that we have. It installs the gems using bundler. It then uses the linkers, which we'll get into in a minute. And then it starts running RSpec and server spec tests. And specifically serverless. Because, and that's pretty wonderful because in our case, 3 versions of Ruby, I don't have to go through and necessarily test those 3 versions. It will come back and say 1.9.3. Almost always says that to me specifically that it failed. And then we can go on from there. So Travis is a very, very powerful tool. Whatever developer you're doing PHP development, check it out. I mean, do it because it's very, very helpful.
So were you on Jenkins before that? Is there a particular reason why you choose Travis over something to manage yourself? It's a pretty high price, about $500 a month for volume.
Well, there's some philosophical things that we do that allow us to use these types of tools. And number one is we focus very stringently on the fact that our data is unique and our code is not. So by separating those out, we're allowed to use public GitHub repositories for every group. And as a result of using public GitHub repositories, you can use Travis for free. If you're having private GitHub repositories and you need to test those, then there's a fee associated with that. It's just understanding your data and your code and learning how to separate it lets you realize these kinds of things.
Yeah, so I didn't mention that. It's free up to a certain amount of usage.
Yeah, I've been researching it a bit. I just trying to understand obviously the difference between say it and Jenkins and
Sure.
We
We definitely leverage Jenkins. We don't use it for our CI for the most part because of the fact that, as Kevin said, we use public repositories. And that's one of the awesome things I actually feel about the media is we put almost everything we possibly can out in the public space. It's out there for you guys to check out. Ruby linters. I would write a lot of Morse code without a linter, but I also hate them. You know, the 2 linters that we use are Ruby copy and Crit. It is similar to the Drupal coder module, that it looks at your code and uses community guidelines to come back and says, the lines are too long. Maybe you should think about using a case statement here instead of an if statement. So what it does is it really helps you write. End goal is write within the community standards, but also write cleaner, more understandable code, and it helps a lot. It's really pretty wonderful. Rubicop and FoodCritic catch different things, and that's why we use both of them. We also have Travis run both of them for us. So, you know, before I do a pull request or push up to Git, I run them, but we also have Travis do as well. And sometimes, you know, we'll find some idiosyncrasies in there and stuff. But they are pretty wonderful if you're writing Ruby, if you're working on Chef and stuff like that. It's certainly some tools to use. They're set up as tasks that you can run from rake in NMD Skeletor. So you go to Skeletor, you do a rake -d, you'll see targets for running Rubicop and targets for running FoodCritic. You can do those and it will run it against your recipes. So Rubicop and FoodCritic, pretty great and pretty powerful tools. So kind of flying through this, but what does it all do? NMD Skeletor is what I use to start recipes, is what we use to start recipes, and it's because it has all these tools. It allows us to really rapidly deploy recipes, and I can hit the ground running using NMD Skeletor to write the recipe, write my tests, and like I said, not go to the backtrack and be like, oh, I want this one thing. It also helps me generate a README on the fly and have these processes and that kind of run through the whole life cycle. So it's certainly out there. And I think it gets you a lot. I think it gets you a lot of functionality and leverages, you know, open source tools to get out there and do your infrastructure as code if you're using Chef. Like I said, a lot of this stuff can easily be reused for Puppet if you're a Puppet guy. I'm also a big fan of Puppet. So you know that stuff is out there and you know, use it. So a quick thing. Questions?
I was just going to see, why do you prefer Chef over Puppets besides like Ruby? That's why you have that.
You know, I think they're both great, and I really don't try and get caught up on the tools. I think they both are great. I think they're both very powerful. We use Chef because that's kind of what we've had a lot of client requirements to work with, but also we've kind of invested in that direction, but we're just as capable as using Puppet as well. You know, sometimes with Puppet I get a little frustrated with DSL, but that's only because I want to break out to Ruby, and it's just forcing myself to think Puppet, effectively thinking Ruby, and there's nothing wrong with it. I think they're both really great, but it's also what's your competency, what works well for you, because they are both great tools. Salt is a great tool, Ansible is a great tool, and we really don't try not to focus on what tool are we using, it's what is the right tool for the right job. And you know, for Skeletor right now, we've built it up for Chef, but we could easily expand it to cover Puppet and Salt and everything else, because a lot of these tools are applicable not just for Ruby, or not just for Chef.
Wait, another reason is that Ruby tends to be more developer-centric, while maybe Puppets or Chef's more developer-centric because it's based on Ruby, while Puppets may be more operations-centric, and we tend to appeal to a larger developer audience than we do to operations people. So from an operational perspective, Puppet might very well be a better choice depending on the size of your enterprise and your deployments. I think the point of a lot of these tools that we have in place are that they're somewhat agnostic in implementation strategies, and the goal is to be able to help you identify the end state of the system that you're working against, and then find ways to target and test that efficiently. And right now, Ruby and Chef Spec and some of the stuff that Opscode's doing is really well suited for that. I'll throw this up here too. Some of the stuff that David went over is outlined in greater detail. If you go to newmediadenver.com/node/83, we have Understanding Team-Based Infrastructure Management as a blog post. It's a series of posts that we've all kind of worked on that show you how to get started doing some of this stuff. So some of the things that may not have been thoroughly explained or outlined in greater detail off of this blog. It's well worth looking at. It gets you some of the basics to get up and running. It's what we use as documentation for all of our new developers to come on board and get them up to speed as quickly as possible.
It is truly a great resource. It goes through step by step a lot of stuff. I just kind of lost over.
Yeah. So with service spec and RSpec, when things go wrong, is there, like, do they do anything to help with the debugging process?
Well, you're writing the tests, right? So, and as long as you start with the tests and your expectation of what should be there, and you're writing your tests very specifically for certain things, so you don't kind of get blown out and say, oh, I'm doing this. You write them per recipe, right? You write one per recipe. So it'll tell you what has failed and what line has failed. And since you're defining those tests, you can easily be like, okay, that one example that I had back on that slide, you can say, okay, this one line in this PAM file isn't correct, right? So as long as you're writing your tests targeted on what you want,
Right.
it'll show you what's
so if you're testing that, they're not always going to be that good.
Right.
They're not always catch up with this.
Right.
So you're, let's say you're writing the test,
Mm-hmm.
and you're trying to test in the box, version you want to have. How are you going to debug that? Figure out what the problem is.
Well, right, and that's why we have two different types of testing, right? We have RSpec on the front end to kind of help you get through the Ruby code piece, and then server spec for the end expectation, and then we have Travis in the middle, right? Because Travis is what we're defining our different environments for. So if you have, and for us, we target 3 different versions of Ruby and then different operating systems, but you can really blow that out if you want to. So that process, because absolutely we're always going to write a test that may not be 100% right, we think it's right, or it's really, really close. But that those, using kind of the whole process that Skeletor kind of sets you up to use, really helps you target and find those things. And it also forces you to write relatively better tests, right? Because you run into that stuff and you go, oh, well, yeah, I should test this. It's hard to go back and write tests for existing code, right? And that's part of the problem. That's why really, if you're going to do test-driven development, it has to start with the tests and not, hey, I'm going to write the functionality and then write the test, because what happens is you write that test. Oh, it's good enough. I know what this means, that kind of thing, or I know it should be this way, and the test gets almost there, and another developer picks it up, something's broken. So, with all these tools, we try and check and balance all the way through, sure, we're finding that stuff. But it is a challenge.
And also, with Food Critic, you're running it locally. You're actually running those virtual machines on your local environment. You can log in, you can SSH into that machine, and you can be like, okay, this is the device we're working on for. Why does this file not have this contents that I think it should have? And you can say, oh, I just log something. So you can inspect everything and go through the actual server.
You don't have to tell Kitchen to destroy the machine when it's done. In fact, when it fails, it won't. That machine will be up. Whether you've targeted local development or Amazon or Docker container, whatever you have, if it fails, it'll be up. So you can, for that very reason, so you can then log into it and look at it, poke around, and then hopefully write a better test.
You can and then you can chain those or stack them. So you could basically say run 12, 14. You could basically spin up 6 different OSs from one rate file test, and you can log each of them. So if you find version 1 or failure 1, so it's pretty useful. Of course, it takes some time because you have to look over that whole test of X operating system, so you don't always want to do that.
And that's one of the real beauties of Test Kitchen, is because of the fact that not only can you target different environments, you can have those machines to go play with, and your RSpec will get you, hopefully, your RSpec test will get you to the point where, like, hey, I'm getting there, server spec, which we run with from Kitchen and jobs.
So is there a way to run tests where you're only running with one version, and then if you run with one version?
Yep. You can make a separate job and target whatever you want. You can target only certain recipes. In fact, if you look, if you look back at that rake.
And you can do it outside of rake even too. So you can just do funnel exec, kitchen, verify, and then the server name.
Yeah. But you'll notice here that like run all the default tests on CentOS 6.4 or G12.04. Those are separate jobs that we call rake that were defined in that rake file. And you also use Kitchen. So I mean, there's a lot of different ways, and there's a lot of really powerful tools. If you guys haven't messed with Test Kitchen and it's something you're interested in, please check it out.
So you're using Virtual. I read that Virtual configure sort of deprecated.
Yeah.
Is that the case, or is Test Kitchen sort of replacement for that in some ways?
Well, Bergshelf isn't deprecated. Bergshelf has evolved quite a bit. Yes. So we don't use Bergshelf Vagrant.
It was.
And basically what we've done is we've tried as hard as possible to stay up with the changes that are happening there. So Bergshelf is to Test Kitchen basically what Bundler is to Ruby. And I think that will be the case for a very long time. It adds the consistency of getting the proper recipes onto these virtual instances that are necessary. And if you look at the way that we implement Berks files, it basically tells you to read the metadata from the chef recipes that you're testing. So that goes back to the entire concept, like I was explaining earlier, of properly identifying your data and separating that. We use the metadata in the chef recipes properly, and by doing so, it allows things like Bergshelf to function in a very thin fashion, so that they get all of the information that they need from the metadata of the recipe and then act accordingly. I think in previous iterations, there was a lot more effort, like you saw in the gem file that was presented here, or the Berks file that was presented here earlier, to specifically lock down things and do all kinds of interesting stuff. But what the community, as far as OpsCode's community, is trending towards is making sure that that's well defined in its metadata, so that it's almost irrelevant. It becomes a very thin skin or a very thin wrapper that goes on top of your actual testing infrastructure, and something that you don't have to worry about quite as much.
It's skill towards the wall. I mean, you keep an eye on it, and you'll see that we're constantly like and suggestions. And if you guys maybe say, hey, you know what, this could be better, throw it out there on an issue. Send us an email. I'm working on some of the stuff, and it's certainly evolving. But like you said, if you look at a lot of the stuff, we're pushing almost everything we can back to the so we have that in one centralized place, and you can extract that. Thanks, guys.
So as far as these presentations are concerned, we're going to keep doing them. We are going to keep talking about the stuff that we do here at New Media and the stuff that I think that other people can definitely benefit from. What we need from you is feedback as far as what you think of these sessions, what you would like to see us do. I mean, if it's, this is a lot of data. There's a lot of moving pieces. We're encouraging you to go and check out these repositories, download this stuff, read that blog post that I put up there, and try and walk through some of this. And the expectation is that you'll have the same success that the rest of us here do, and anybody else that can follow these instructions will. So our goal is to help elevate you to the point where you can engage in these conversations, and then we can come up with cool stuff. Now, I don't even know what's going to happen next. So if there's anything that you would like to see us talk about, if there's a format change that you'd like to see, maybe some more hands-on stuff, or I don't know what comes to mind, definitely let us know, because we're looking for feedback. Yeah. Well, thanks, David. That was pretty awesome.
Okay, the office will be open till about 8 o'clock. There's still a pizza, there's still